So quadratic functions and their graphs are identified by a few different forms of this function. Now the shape of this function is called a parabola. Okay, so if you take a look at this shape here, this kind of U shape is called a parabola, and this is what defines a quadratic function. And we can show the quadratic function in a few different forms. This form here is called the general form, and basically it's the linear function. If you look at bx plus c, and we're adding on another term which is just one power higher. Okay, so this goes from linear to quadratic by adding this ax squared part of it. So here we have another form which is called the graphing form, and the a's here are actually the same a, but the p and q are different than b and c. The p and q allow us to find the vertex. Okay, so this general form doesn't allow us to find the vertex, but this graphing form does. And we have these different forms of the parabola that tell us different aspects of that function. So we need to be able to relate the in fact there's going to be three different forms. We're going to need to relate these different forms to different parts of the function. So when you look at the graph of the parabola, the first thing that you should notice is the fact that this is symmetrical. And in fact, that's the most important kind of piece of this feature of this quadratic function. It's symmetrical. Anytime we have symmetry in math, we always try to take advantage of it. So the symmetry lies across this line. Okay, so that line is called the axis of symmetry. So we can fold across that line. And the vertex is going to be the most important part of this parabola. That's by far the most important piece because it identifies, first of all, the bottom or top of it, depending on how it's oriented. And it also allows us to find the axis of symmetry. And that point is called the vertex. Okay, so this is the most important part that we want to identify. And when we see that point, all of a sudden we end up getting double the information, because once we know exactly where that is, we know that everything that we know about this graph can be reflected to the other side. So we end up with double the information once we know the vertex. So B are the roots and zeros. So we always want to know where things cross the x-axis. These are called roots, okay, because these allow us to solve equations later on. Okay, and it also tells us something about the graph. The nice thing about the roots, and again, this is something that I want you to recognize and start keying in on, is the roots are symmetrical about the axis of symmetry. Okay, these are symmetrical points. Okay, they're equal distance from the middle, and they help us establish symmetry then. So the roots are important that way, although they don't tell us where the symmetry is directly. Through the roots, we can find the symmetry. C is the y-intercept, okay, and in fact C, because it's not a symmetrical point, we don't really know what the point's over there, although we could easily find it. It's probably the least important point on that graph, but when it's in the general form, it's actually very easy to find, so we keep it in there. Okay, the y-intercept, just like we have a y-intercept for the linear equation, this y-intercept is useful as well in that it is easy to find. Okay, it's a very convenient place to find. The y-intercept also indicates where the function starts at. Okay, if we're dealing with some word problems or a problem in context, this y-intercept is often quite useful because it tells us where we're starting from. Okay, so here's an example of a quadratic function in general form. Okay, now I want you to graph this on your graphing tool, okay, preferably Desmos, and sketch what this graph looks like. Okay, so I want you to do that on your own. Okay, pause the video and do that on your own, and you can check to see what I get. Okay, so when I graph this, I'm just going to type it in, 3x squared minus 2x minus 7 Okay, so I'm going to get a graph that Okay, when I sketch it in, my vertex is kind of somewhere around there. It's not quite on the y-axis, and it's going to kind of go something like that. Okay, so if you touch that on your graphing tool, you can probably find that point. With my graphing tool here, I have to do something a little bit different. Okay, so I'm getting the minimum point as positive 1/3 along the x and negative 7 1/3, so it's negative 22/3 for the y coordinate. Okay, so there's my vertex. That's probably the most important part. Okay, the axis of symmetry then is going to be at through x equals 1/3. Okay, the y-intercept, this point here, the y-intercept happens to be at negative 7. Okay, so there's my y-intercept. And then the zeros of this function, these points here, I have to find those zeros. Okay, you can probably just touch the screen on Desmos and it gives you the zeros. For me, I've got to calculate this. So 1, 0 here is at negative 1.23. And this coordinate here is at 1.896. I'm going to round that to 1.90. Okay, so those are my zeros, my axis of symmetry, my vertex, and my y-intercept. Okay, and again, notice that the zeros are symmetrical about the axis of symmetry. The last thing here is the domain and range. Well, the domain of a quadratic function is what we can substitute for x, and basically any number goes. So the domain of this function is going to be x is all real numbers. Okay, we can write it in interval notation like this, from negative infinity to positive infinity. Okay, this is what we call interval notation. These mean the same thing. The range of this function, well, it just keeps on going up forever, so the top of it is infinite, but the bottom of it, or the vertex, is how we determine the range. So the range is for y is going to be greater than or equal to negative 22/3, and y is an element of all real numbers. Okay, we generally don't need to write that in. Okay, but if we were to use the proper notation for this, we'd use these nice little brackets and all that. Okay, so in fact, if we were to write this properly, maybe I should write this out properly. It would be y, and then y is greater than or equal to negative 22/3, and y is an element of all real numbers. We start using this interval notation, and it's going to look like this. Okay, so that square bracket means it's equal to this endpoint, and then it goes all the way up to infinity.